Thanks for coming back again if you have subscribed. If you are yet to subscribe, please help us. Click on the subscribe button and also on the bell beside it to notify you when we drop a new video. This content we are meant to prove that the gamma function of 1 over 2 is equals to square root of pi. So how can we actually prove that? So I'll get our way out. So let's start by saying this. Anyway, from the other video, we've explained it truly, but we just have to make it clearer. So the gamma function, by the definition of gamma function, if I have gamma function of x plus 1, is the same thing as the integral of 0 to infinity of e raised to power minus this dot this raised to power x d this. This is the meaning of the gamma function. So, however, we have gamma function of x, so and the difference is just going to be x plus 1 here only. So this is the definition of gamma function. So if I have this, how can I prove that? How can I prove that this is equals to this? So let's proceed. So I have the integral of 0 to infinity of e raised to power minus this dot this raised to power x, then the b. So let's this equals st. So if this equals st, so definitely not partial derivative, so db will be s dt. So with what I have here, so I can actually proceed. So I can now say that the integral of 0 to infinity of e raised to power, this gives us st. E raised to power minus st dots, then we have this means st, so we have st or raised to power x. So don't forget that we can also have that the db is this, so meaning that if I'm going to change the content in terms of dt, so I'm making this a set of formulas, so dt is going to be what? Probably, yes, we can actually prove this, so no problem. So we have db here becomes s dt, so I have dot s dt. So let's proceed. So what I have here next is the integral of 0 to infinity of e raised to power minus st. Are you following, guys? So then I have x raised to power x, s raised to power x dot t raised to power x dot s dot dt. So what next? So don't forget, this is the gamma function of x plus 1, and that is what we have been evaluating. So now let's move, so then we can have this s and this s come together. So, and that gives us the integral of 0 to infinity of e raised to power minus xt. Then that gives us s raised to power x plus 1, then dot t raised to power x to t. So if I rearrange very well, I'm going to have integral of 0 to infinity of e raised to power minus st dot t raised to power x dt dot x raised to power x plus 1. So if you look at this very well, what I got here is the same thing as what is here for the b. So meaning I've gotten the Laplace transform of t. The Laplace transform of t raised to power x rather. So we can actually write this as, are you following? So meaning that the gamma function of x plus 1 is the same thing as the Laplace transform of t raised to power x multiplied by this, that is x raised to power x plus 1. So that is for this. So next, let's x equals minus half. If x is minus half, what would happen here? So meaning we're going to have the gamma function of, this is minus half plus 1, so that gives us half, equals the Laplace transform of t raised to the power minus half dot, and this gives us x raised to the power half. That is what we have. So meaning that the Laplace transform t raised to the power minus half will be equals to the gamma function of half all over the s raised to the power half. So let's note this. One thing we have to note in this process. So then we go on to evaluate the Laplace transform of t raised to the power half to get our answer. So now let's evaluate this and compare our answer with this. So whatever we get here, we compare with this, and it must be the same to prove that this is equal to this. So that is just what is there. So now let's move. So let's go. I have the Laplace function transform. So let's take it this way. The Laplace transform of t raised to the power minus half would now be equals to the integral of 0 to infinity of e raised to the power minus st dot t raised to the power minus half dt. Yeah, we have this. So the next line of action is to say let y squared equals st. So if y squared equals st, meaning we're going to have 2y dy, that is differentiating explicitly, and this will give us s the t. So from there, I can make the t the subject of the formula. So dt is going to be equals to 2y dy all over x. So I have this. Don't forget, I put that back into the integral. So what would I have next? I'm gonna have this, the integral of 0 to infinity of e raised to the power minus y squared. So this is what I have. Dots. Then this gives us t raised to the power. Don't forget, I have to make one or two things from here. You should know that y squared equals st. So definitely t is going to be equals to what? Y squared over s. So if I put that here, I'm going to have y squared all over s, or raised to the power what? Minus half. So I think we're getting it, guys. So now the next thing is the t. The t becomes 2y dy all over x. So then I have to mix all together. So I gotta achieve our a. So meaning I'm going to have the integral of 0 to infinity e raised to the power minus y squared, and this gives us y raised to the power minus 1 all over. This gives us s raised to the power this gives x raised to the power minus half dot this gives us x raised to the power minus 1 dot 2y dy. So just keep looking as we continue to simplify what we have here so we can get this. So now I would have to rewrite these on one part of the board. So sorry, excuse me. So if I'm to rewrite this, I'm going to write it at the lower side here, so that t raised to the power minus half is the same thing as the gamma function of half, or raised to the power s raised to the power half. Sorry, all over s raised to the power half. So let's go. So from there, I continue to simplify this. So then I have the integral of 0 to infinity of e raised to the power minus y squared, and this gives us dot y raised to the power minus 1, and this is dot s raised to the power half. Since this is 1 over s raised to the power half, so that will give us s raised to the power half. So multiply by s raised to the power minus 1, then with 2y dy. Anyway, you can bring out the 2, no problem. So then what next? So then I have the 2 integral of 0 to infinity of e raised to the power minus y squared. Then here we're going to have s raised to the power half multiplied by s raised to the power minus 1, and that gives us s raised to the power minus half using the law of indices. So and this gives us this y and this y raised to the power minus 1, so that gives us y minus 1 plus 1. So and that gives us 0. So meaning y raised to the power 0 is going to give us 1. So y disappears. So we have 1 then dy. So from there, I can actually bring this out. It means 2 all over s raised to power r. If I have this, yeah, because this is 1 over s raised to power r into, or probably integral of 0 to infinity of e raised to power minus y squared to y. This is what I have now. This is the little thing I have now. So I have actually simplified up to this level. So now we can actually proceed, okay, using the, let's say, just similar to the Gaussian integral, but however this is 0 to infinity, not minus infinity to infinity. So we can say the value of this is equals to half of square root of pi. Yeah. So meaning we're going to have this, which is 2 all over s raised to power half multiplied by the half root of pi. So this gives us the half root of pi. So it means this goes with this. So then I have the square root of pi all over s raised to power half. Don't forget that is equals to the Laplace transform of t raised to power minus half. So and if that is the case, we can compare with this. So meaning comparing this side with this side, the Laplace transform of this is the same thing as this. So putting what we have here to this side, then I'm going to have the gamma function of half all over s raised to power half all equals the Laplace transform, which is now this, the square root of pi all over s raised to power half. So comparing what we have here, you see the denominator are equal to each other. So definitely the numerator are equal to each other. So therefore, we have proved that the gamma function of half is equal to square root of pi. Thanks for watching. Please subscribe to our YouTube channel. It's free. Thank you.